Brad Williams, Frugal Finance, day count conventions. What does this have to do with swaps? Throughout our discussion of swaps, we have abstracted from the technicalities of the exact interest calculation that is used in actual market transactions. This choice has allowed us to avoid some tedious math to focus on the economics of the swap market. This section provides a brief overview of the actual conventions employed. The basic interest rate swap involves a series of fixed rate payments associated with a long-term instrument against a series of floating rate payments tied to the money market. The bond market and money market use fundamentally different assumptions about day counts and interest computations. In the money market, interest payments are generally computed on the assumption that the year has 360 days and that interest accrues each calendar day. For example, a SOFR rate of 8.3% on a notional principal of 10 million over a quarter period of 91 days would generate an interest payment of 10 million times 0.083 times 91 divided by 360 equals 209,805.56. So this would be actual 360. As this example indicates, money market yields are computed according to a day count convention of actual 360. In the bond market, two different day conventions are common. One is actual 365. The other is 30/360, assuming that the year has 360 days and that each month has 30 days. For most bonds, the actual 360 convention applies. For example, a 100,000 par value treasury bond with a yield of 8.3% for a semi-annual period with 182 days would generate an interest payment of 10 million times 0.0830 times 182 divided by 365 is equal to $413,863. Because these conventions differ, it is important to take their effects into account in swap contracting and cash flow computations. For example, consider a 2-year plain vanilla interest rate swap with semi-annual payments. The terms are an unknown SFR against 6-month SOFR. The notional principal is 100 million. The 4 6-month periods covered by the swap have 182, 183, 181, and 182 days, respectively. The fixed side cash flows are computed on an actual 365 basis, while the floating side cash flows are computed on an actual 360. The basic no arbitrage pricing condition requires equality in the present value of the fixed side and floating side cash flows. On the swap, the first cash flow is 10 million times SFR times 182 divided by 365, and the first floating cash flow is 10 million times SOFR times 182 divided by 360. Differences in day count conventions affect each cash flow, the present value of the two sides of the swap, and the swap rates. As an example, we price this 4-period swap in the term structure environment of table 2213. First, we price it according to our simplified equation 22.15. Then we price the same swap considering the day count conventions. For the simplified equation 22.5, the numerator and denominator are as follows. So here we have the numerator, which is going to be this number. Remember, we have this 0.03 divided by, and then so on and so forth. And we're going to generate this number here. Then we have a denominator, which is, here's your FRA, and then here's your 0. So now we have 369,352. The SFR denominator, numerator, equals 0.123917 divided by 3963 to determine the SFR rate of 3.35%. Annualized, this is going to be this number times 2. We now compute the SFR taking the day count convention into account. The 4 semi-annual periods have 182, 183, 181, and 182 days, respectively. The fixed rate payments are computed on an actual 365 basis, while the floating payments are based on an actual 360-day assumption. The basic computation is the same as in equation 22.5, except the fraction of the year cannot be factored out, as it differs for each payment and differs between the numerator for the floating payment and the denominator for the fixed payment. Taking the day count convention into account, the present value of the floating payments is as follows. PV floating equals notional principal times FRA times 182,360 divided by Z plus FRA 183 divided by 360. That'd be period 2. FRA 2 of 3, 181,360, and so on. Here we have 0.069 times, and then it's plug and chug. Got that? So in the end, here's the formula. We have 0.12528,763. The present value is going to equal N of P SFR times 182,365. Notice? Now we're doing actual 365 versus actual 360. Plus SFR times 183. And we're going to use this formula, E73, right here, times 10 million. 100,000, this whole thing here, and we're going to get this number. We're going to get the number, then we're going to get 184,179. This is your SFR. SFR equals 18417 times 179,200. Because we're not factoring out the expression for the fraction of the year, it differs for each payment. Note that the FRA rates that appear above are the annualized rates. To compute the SFR, we equate the present value for the fixed and floating payment streams and solve for the SFR. Floating equals PV fixed, 1258 SFR times 184,179. So we get this SFR of 12.5 million divided by 184.1 million equals 0.68025. Right here, we've got this simple. The SFR is already in annualized terms. The annualized SFR, according to the simplified equation 22.15, is 0.06100 compared to an SFR of 0.68025. Taking the day count convention into account. This is a difference of 9.25 basis points, a significant difference that needs to be considered in actual swap pricing. Brad Williams, Frugal Finance, more to come.